We are Team 3 from COMP3001. Our project revolves around using TfL's open data set to establish the optimum places to install new or modify existing bicycle hire racks, minimizing the need to pick up used bikes and move them to the appropriate hire racks. Our main project goal is to build a web application for TfL to visualize the position of docking stations across London and volume of inflow and outflow of cycle traffic at each station at peak times.
For our initial project plan, we created a detailed Gantt chart to guide us through the stages of developing this application. Furthermore, we used an agile approach, having weekly retrospective reports following the Scrum methodology. The team was divided into 3 main subgroups: backend, frontend, and analytics. A team leader was designated for each group. Team members were also given the flexibility to move between groups according to their proficiencies. This diagram clearly shows different stages of our overall project plan, beginning with research, following through design, and finally the building and testing stage.
The first stage was research. Each subgroup was allocated specific tasks. The back-end research looked into ways to store data and web hosting options, ways to convert data format, and checking the compatibility of TfL data. The analytics team defined our main goal for the project and researched into using additional datasets. Additionally, the front-end team looked into visualization libraries most suitable for the ultimate user interface and user experience. In the design stage, the research was taken into careful consideration and specific choices for the datasets, database, analytics, and user interface was chosen. The exact same research tasks had now been put into design by the subgroups. Backend development was ahead of schedule. We successfully converted the CSV data to JSON, set up and loaded data into the database, and created an API. However, indexing the historical journey data took longer than planned. The core of the solution relied on programming an analytics algorithm which would be fundamental for our visualization on the website. This was to be completed by the 5th of December.
Testing began soon after development. We focused solely on unit testing and security testing for the backend. For analytics, the plan revolved around testing the designed algorithm to the tested algorithm. Usability is fundamental for the front end, hence why we paid careful attention to the user testing. We also carried out cross-platform testing and a heuristic evaluation. Now for the contingency plan. Our MongoDB is limited to 40 GB. If our choice of datasets meant we exceeded the limit, we would have to prioritize datasets carefully based on our requirements. During the development phase, a poor MongoDB performance would mean having to move data to Postgre. Also, an inability to complete our solution within the time limit would require us to allow the most proficient individuals to complete the tasks. Now for our solution in detail. Firstly, we created a web application for TfL to visualize the position of docking stations across London and the volume of inflow and outflow of cycle traffic at each station at peak times. Secondly, we created a flexible REST API for end users to perform analytics on the historical journey data in our database.
So here we have the visualization that the team has created. This visualization represents every bike rack that is in the Barclays cycle hire scheme, and each of these bike racks is represented by a coloured marker. The colour of the marker depends on the log of the total bikes in divided by the total bikes out. This total number of journeys is taken from all the historical data of journeys between 2012 and 2013. The user can select 2 different times here, morning rush hour or evening rush hour. The analytics team identified these times as the most likely for problems to occur in lack of bikes or available bike spaces at stations. So you can switch between these 2 like this and you'll see the visualization changes. So if we look at morning rush hour, you can select the threshold of the value of the log of total in over total out. So if we increase this threshold to 2.22, you'll see that there are only a few bike racks remaining. These are bike racks whereas there is the highest skew of bikes in to bikes out, or vice versa. The darker blue markers denote a high volume of bikes leaving the station compared to the volume of bikes entering the station. Darker red markers denote a high volume of bikes entering the station compared to the volume of bikes leaving the station. So you can see here that TfL might want to consider expanding these particular sites to provide extra capacity in the network at the highest volume times. Similarly, you can look at the evening, and the problem is clearly less pronounced in the evening as no bike racks reach this threshold, but if we bring it down, the main problem areas will start to present themselves down to the entire network here. The data for this visualization was taken from the historical data. The team has collated this historical data into a Mongo database, and this is accessible through an API that we have created. The API is documented on our website here and is a REST API, and all the data can be accessed from that. This way, users can create their own visualizations to meet their needs.
For future development, we are looking into three main areas. First, we want to expand the API according to future requirements from stakeholders. Next, we want to incorporate the live data into the database, thereby making it accessible through the API. And finally, we want to implement machine learning algorithms like clustering or genetic algorithms to predict future patterns.